right? So the next, we know how to predict one line of X, incoming predictions, but we want to learn we want to learn how to predict all of them at once, right? Not just one line. So let's think of how we could do it. Well, we could do it if we wrote a function called predict, right? So we'll call it a function called predict, and the predict function should predict almost the same, let's say, right? Well, I'm going to accept, and then no, that's not what I want. Right? I want to predict for the entire data set X. So this is more than one, same classes, node, blah, 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 right? So that's correct. Now I want to, so there is a way, well, see, why don't we try generative AI here, then I'll explain, like if it can solve our problem, then I'll explain how it works. So let's see. So we'll say apply predict 1 to entire X data frame, right? So let's see if generative AI can do it. Right, so it did one way of doing it is this, right? So it used list comprehension. I'll explain what's going on here. We already looked at list comprehension at least 2 or 3 times in this lab. So whenever you have some sort of an expression inside square brackets, that means that a list is created. So let's see what list is created. It is created for all X values. So it'll go one by line. It'll be taking values of X line by line and then putting them in X. That's what for X in X values says. And then the function which precedes it will be applying whatever is there to this X. So it will be applying predict to every X. And the return will be this list. Nothing wrong. This is actually a correct solution. This is a fine solution. I have no problem with it. We could use that, but let's see if what else it's suggesting. Right? Okay, that's about similar. So what it's not suggesting is the solution which I want to use here, but like nothing wrong with these suggestions. Totally, you can use these, right? It's just the return value will be a list, which I don't want to do. What I want to do is I want to do, like I said, I want to create a function called predict. X classes node, right? And then, no, that's not what I want to do. I want to apply, I want to do the following. Oh, wait a second. There was something yeah, X apply, right? So I think this looks right to me. Yeah, this actually does look right. I'll just say return. You see, autocomplete actually worked in this case. You don't have to do it through autocomplete. Obviously, you can. You should be able to run it yourself, right? Like this. But yeah, let me explain what's going on here. So here, it's exactly the same function, and I kind of, like, it's prompt engineering is sort of important with generative AI, and it's changing thing. If you're watching my video like 2-3 years later, it'll behave differently, but I'll explain what it's doing. So predict 1 predicts only one line. So all I want is exactly the same thing, but instead of just giving it one line, like as we agreed in predict 1, I will be giving it like the whole data frame, and I want it to work on a whole data frame. So when I started typing, it kind of figured that that's what I want. And this is what I want. There is this function called apply in the data frame of pandas. So it's in pandas, it works for pandas. The previous, suggestions by generative AI using list comprehension were not using the fact that it's pandas. They were using something else. They were going through iterators. But in pandas, there is this function called apply. It's a very powerful function, and it's from function. It's from the field of programming called functional programming. And if you're coming from R programming language background, you would be using this apply left right. So you should be very familiar with how it works. But the idea how it works is the following. X apply, whatever is inside this apply will be a function, and it will be applying to this data frame, to every line of the data frame. That's how it's going to work, right? Because I created this lambda. Lambda is a function, remember. This is an anonymous function. I created it on the fly, like you're creating the function and using it right there. I didn't give it any name. I could do it from def, but I did it from lambda. And the function itself is simply predict 1x, blah, blah, blah. The reason I'm creating lambda is because it has to be only one value. That's why it's doing lambda. Right, it has to be a function of one argument. That's why I'm creating a lambda x, but classes and nodes are coming from the argument of the function. And axis 1, it tells you like it takes like lines, right? So I'll do that, and then now I can predict the whole thing, right? So why don't we predict for the entire x now? It seems like this should work. I think this will work, right? So we can then print it. Let's see. Right, so it made predictions for entire dataset, you see. And if you remember for Mazda RX-4, it was predicting 4 when we were using a shallow tree, right? So let's have a tree of depth 2 and see what that guy does. You see, it's very interesting for depth 1, when there's only one branch in the tree, right? For a tree like this, where there's only a root and then like one level. Mazda RX-4 is predicted to have 4 cylinders, but then if we can build a tree with depth 2, right, like this guy, with 2 levels at least, then let's look at the prediction for Mazda RX-4. Yeah, here is 6. Prediction is changing. Why? Well, because the tree is different. So if we're fitting one level tree versus 2 level tree, the trees are different. And because trees are different, well, the outputs are different, right? So now we actually were, basically, we're done with prediction part of this lab. So you can stop here if all you wanted was to predict, the instances. But now we have all the tool set to actually create the cross-validation, right? So let's work on creating the cross-validation setup. What do I mean by cross-validation? We will be taking the sample, this x, instead of predicting it on x, it's in sample, right? We trained on the entire x, and now we're predicting entire x. That's in sample. If we're overfitting, we won't notice that we have an issue, right? So instead of doing this, let's train on the part of x, and then apply and test, validate on the remaining of x, right? So that's what we're going to do next.